Hello, this is Mike here, and in this video we're going to go ahead and learn how to solve an absolute value equation. And in order for us to solve an absolute value equation, we're going to have to remember one important fact, and that deals with whenever the absolute value of x is equal to, we'll call this k, where k is greater than or equal to 0. K is greater than or equal to 0, so that basically states that k must be positive or equal to 0. This implies that x equals positive k or x equals to negative k. So x can equal to positive k or x can equal to negative k. A lot of times we see it written like this. X equals to plus or minus k. They put the plus or minus up on top. But that only works when this is set equal to a positive value. It does not work if k is equal to a negative, because the absolute value of x is only positive. The absolute value of x is only positive. If we look at the absolute value graphically, let's look at the absolute value of x graphically. So if we look at f of x equals to the absolute value of x, this is a function that actually has a point or a corner that exists at the origin, and then it exists in such a fashion. So he is actually the composition of two different functions. We'll get into the absolute value of x a little bit later on as we progress through this lecture series. But for right now, we recognize that everything about the absolute value of x is always above the y-axis. He's always positive, because whenever you take the absolute value of any positive or negative number, he's always positive. So if we take the absolute value, for example, of 2, the absolute value of 2 is positive 2. But if we take the absolute value of negative 2, if we take the absolute value of negative 2, that is also equal to a value of positive 2. So no matter where we are, we're going to have that same value only being positive. So let's go ahead and try an example. Let's go ahead and try an example of solving an absolute value equation. So let's try an example, and the instructions will state to solve. So let us say the absolute value of x equals to 3. Relatively simple. This implies that x either equals to plus or minus 3. And yes, it's just that simple. It's just that simple. And we can plug them back in to check. I think that's somewhat trivial, but let's go ahead and try another example. So we're going to say to solve, the absolute value of x is equal to 0. And again, when we take and we get rid of the absolute value, we can apply our formula by saying x equals to plus or minus 0. But remember, plus or minus 0 is still a value of 0. So there's no plus or minus 0, because 0 is always 0. So let's go ahead and expand a little bit further and add a little bit more of a try, a little bit more of a difficulty trial to our problem series. So let us say we have the absolute value of x plus 2 is equal to a value of 6. So we have an absolute value set equal to a constant. That constant's positive. So we're going to say that x plus 2 equals to positive 6, or x plus 2 equals to negative 6, because this has to be set equal to a positive or negative value. So this implies that we can subtract 2 on both sides over here. So we get x equals to positive 4, and we can subtract 2 on this equation, and we're going to get x equals to negative 8. So we have two solutions here, and you're going to see the solutions often written as a set. So you can write them as negative 8, comma 4. And remember, this does not equal to negative 8, comma 4 like such. And it doesn't equal to negative 8, comma 4 like such. This could either be a point or an interval, and this is an interval. This actually means 2 points, negative 8 and 4. So be very careful, and if you were to plug both of those in, you would get a valid solution. Okay, let's try another example. Let us say that we have the absolute value of x plus 3 plus 4 is equal to a value of, let's say, 5. So the first thing we want to do is we want to isolate the radical, because we only have the form of the absolute value of x equals to a constant. So we have to isolate the radical by itself. So the absolute value by itself. So we're going to subtract 4 on both sides. So here this cancels, and we get the absolute value of x plus 3 equals to a value of 1. And now from here we can delineate and determine our two solutions, and we know that x plus 3 equals to positive 1, or x plus 3 equals to negative 1. Solving, we're going to subtract 3 on both sides, so we get x equals to negative 2, or we can subtract 3 over here, and we get x equals to negative 4. So notice we get two solutions, and we want to plug these in to make sure we're correct. And let's go ahead and plug in one and see how we do. We're going to get -2 plus 3, all plus 4. -2 plus 3 is -1. Absolute value still plus 4. Absolute value of -1 is +1 plus 4, and that gives you a value of 5. I'm going to go ahead and let you plug these in just to make sure they are correct. However, I do encourage always plugging in to make sure that your solutions are correct. Okay, let's go ahead and try another example, and I don't mind if you pause the video in between these examples. It might be helpful. Let us try solving the absolute value of 2x plus 3. Plus 5 is equal to 3. Okay, so let us go ahead and start this by subtracting 5 on both sides because we want to isolate that radical. And now we get the absolute value of 2x plus 3 is equal to a value of -2. And this should scream something in your head. It should scream to you because notice an absolute value is set equal to a negative. And remember, the absolute value in order to solve must be equal to a positive greater than or equal to 0. So this means that we do not have a solution. This means we do not have a solution because we can never have an absolute value ever equal to a negative. An absolute value must always be positive. So be very careful about that. And that's really the extent of the difficulty of these absolute value questions. You want to isolate them to set the absolute value equal to some constant and make sure that constant is positive.